All right, so this particular recording is not going to be terribly long, but it is going to, it's going to get a little bit complicated. So just bear with me as we go. We're stepping backstage, trying to have a look at what's going on in the F test. So firstly, imagine we're doing an F test on both of these. Which of the two options do you think is going to give a smaller p-value? So which one is going to have more evidence against the null? And I've put the null hypothesis there. Have a think. So the smaller the p-value, the more evidence against the null, the more it looks like not all of the means are the same. So if we look at A, and using the medians as a bit of a proxy for the means, so I draw this kind of squiggly line here, that's what we call the variability between groups. So the variability between the three group means, right? This one's a little bit higher, bit lower again, but there's not a huge change there, right? There's not much variability between the three group means or medians. In this situation, quite a lot of variability. So this one's quite a bit lower, these two are kind of closer together. So in which situation does it look more like we're going to be able to say, oh, well, actually, we don't know, maybe all the means are the same? Leave this one here. Oh, that null hypothesis is incorrect. We've got too many groups. I've obviously copied and pasted it from elsewhere. Okay, so which one's going to give us the smaller p-value? This one, because it's giving us more evidence towards the alternative, that not all of those three means are the same. Okay, so you always want to have in your mind a picture of what the data should look like if the null hypothesis is true. Okay, if all the means are the same, you're expecting to see all the groups kind of at the same level. If what you're seeing is different from that, you've got a chance you're going to get a small p-value. So we're going to revisit the reading methods example, and we're going to have a look at how everything went down. So this was the output from the test from SPSS. We're going to have a closer look at where all these numbers came from. So firstly, what is F? F is F0. It's the test statistic for the F test. We've seen two different types of test statistics so far. The test statistic from the randomization test and the t-test test statistic. This is a third one. So this top definition, this applies for any test statistic. Always a measure of the discrepancy between what we're observing and what we're expecting if the null is true. So just like in that starting question, right? In terms of which one, well, where's the biggest discrepancy between what we're observing and what we're expecting if the null is true, right? If the null is true, we're expecting three little identical boxes, yeah? So which one looks the most different from that? B. So B is going to have the bigger F test statistic, which is going to give us the smaller p-value. This is technically what the F statistic is measuring. Okay, it's a measure of the ratio of the between group variability, so that's how much variability there is between the means, compared to the within group variability. So within group variability is how spread out the data is in the group. So let's look at it a bit closer. So on your formula sheet, you do actually have a formula for F0, S squared B over S squared W. So S squared B is that measure of the between group variability. So that's shown by the like red oval. So you can see the three, each group's mean there. So SB squared is a measure of how varied or how much space there is between those three means. But we compare that to that with in-group variability, which is how spread out the data is within the group. And that's like shown by the green ovals. On the output from SPSS, we ignore that first box, the sum of squares, and the mean square box, that's where our SB squared and our SW squared are. It even says between groups on the table and within groups. The between group variability has a measure of 9, the within group variability has a measure of 2. To calculate the F statistic, we just divide top one by the bottom one, and it equals 4.445. That's simple. Okay, so it's always the top one divided by the bottom one, just like a fraction. Okay, have a real think about this one. So 2 scenarios again, same sample sizes, same means. The means are shown by the little orange bars. But as you can see, from scenario A to scenario B, we've changed how much within group variability there is. So the data itself is much more spread out in scenario A. Which is more likely to give a small p-value? Okay, which one, for which example, is there more evidence against the null? So thinking about the 3 things that are going to impact on the size of our test statistic, and which of these is going to give us the smaller p-value? Okay, so let's zoom in. So let's look first at scenario A. So here are the 3 means. Now imagine I've built a confidence interval for each of those means. The confidence interval is going to be quite wide because of the variability in the data for that group. So this is an example of possibly what my 3 confidence intervals look like. So if we look at sample 1, that's a range of plausible values for the mean for group 1. Well, contained in that are some plausible values for the mean for group 2 and some plausible values for the mean for group 3. So it's plausible here that the 3 means are the same. And remember, our null hypothesis is that the 3 means are the same. The null hypothesis here is plausible. So this would give us a big p-value. Scenario B, same thing. If we pop the means on and we build confidence intervals, because the data is so condensed, so consistent, our confidence interval is going to be really narrow. So you can see there's no overlap here between the plausible values for mu1 and the plausible values for mu3, and obviously mu2 would be even higher. So in this scenario, the underlying means are probably not the same. So in this case, we would get a small p-value. Okay, so it's kind of an example of how the variability within the groups is going to have an impact. So the greater the variability between the groups, so that's the group means. So if you're trying to show evidence that the means are not all the same, then you want the means to be really, really different. So if the means in your data are really different, that's going to be helpful. And you have to compare that though to how much variability there is within the group. What you want ideally are these nice tight little bundles of data that are really distinct and separate from each other. There's so much overlap in this one that they could all be the same. So to get strong evidence against the null, we want big variability between the groups and really consistent data within the group. And what will happen is in our calculation, SB squared, we want that to be large over here relative to the variability within the groups, and that's going to give us a large test statistic, which is going to give us a small p-value. So that is quite a lot to absorb, but hopefully you're starting to see how the F test statistic comes together. What I want to show you now is how the test statistic and the p-value, or how the test statistic gets you to the p-value. So we don't have an T distribution this time, we have an F distribution. And the F distribution, it looks really smushed up like this. And you might remember back when we did chapter 3 and we did the randomization test, when we did the randomization distribution for 3 groups, we got something that looked kind of like this as well. We didn't get a nice symmetric distribution around 0. We got like a really squished up distribution of the left side being 0. So same kind of deal here because we're looking at more than 2 groups. Now the F distribution, it has 2 degrees of freedom. The first one comes from the number of groups, and the second one comes from the total sample size. That's all the groups together. So for the example we had of the reading ages, we had 4 groups. So 4 minus 1 is 3. And the F2, the total sample size was 50, I don't remember, 50 minus K, which is the number of groups, minus 4 is 46. That's where these 2 numbers came from. Okay, and this is on your formula sheet, the calculations for degrees of freedom. So you just have to remember K is the number of groups and N is the total number of observations. So the p-value, I said before that the F test is always a one-tailed test because we've only got this one-tailed asymmetric distribution. You plot on your test statistic and then your p-value is the area to the right. And I'm just going to show you quickly sort of what this distribution looks like. So here it is. It's not a very beautiful drawing of it. It's kind of smushed down, but you'll see why. If I put in a test statistic of 2.5, there is my p-value. You can see 0.2-ish. Okay, and that's if we've got 4 groups and a total sample size of 63. If my sample size drops down, you can see what's happened to the curve, right? So it kind of squishes towards the left and it's dropping that tail. Oh, too far. Okay, so the bigger my sample size, the more this tail kind of squishes, but it hardly changes at all. The big difference is sort of up here. This doesn't change much at all. Yeah. Big changes happen when I change the number of groups. So if I have more groups, my whole distribution shrunk up, the tails got flatter, and my p-values got smaller. And if you think about this, it's a lot more difficult to have 9 groups all have exactly the same means than it is for only 3 groups. So chances of being able to say, no, the null hypothesis is not right, all the group means are not all the same, it goes up when you have more groups. If we have less groups, you can see my p-value getting bigger and bigger. So the number of groups really does change the F distribution. What does this all mean? It means that when we do a t-test, regardless of the degrees of freedom, a test statistic of more than about 2, you're usually looking pretty good. But that's not the same here. Because the distribution changes shape so much, a test statistic of 2.5, when you've only got 2 groups, it isn't nearly big enough. But a test statistic of 2.5 when you've got 11 groups is plenty big enough. So you can't really read the test statistic before you've calculated the p-value. You need to know the F distribution. As far as what you'll be assessed on goes, you need to know how to calculate the degrees of freedom, and that's about it. Okay, so similar to other tests, small test statistic, big p-value, big test statistic, small p-value. Okay, that takes us to the end of the behind the scenes. I just want to take a minute and talk to you about the exam. So it might seem like a way off yet, and you're probably elbow deep in assignment 3, which is good because it's assignment 3 is really good practice to consolidate all this new learning you're doing. But you do want to start in the back of your mind thinking about the exam. And the reason I say that is that we don't have all that long left. 1, 2, kind of 3 weeks of lectures left. And you don't want to leave all your exam prep until right at the last minute. It's just going to be too difficult. And the exam is pretty weighty. You're looking at least 50% of your grade. So a few things to think about. Firstly, the exam is predominantly chapters 8, 9, and 10. And we obviously haven't even covered chapters 9 and 10 yet. So what you want to do is probably sometime this week or next week, you want to go through the past exams that are on Canvas, mark off the questions that are chapter 9 and 10 and kind of ignore them for now, and start doing some practice on the chapter 1 to 8 questions. Because the earlier you can do that practice, the better. Because we've got so much hypothesis testing in the exam, you can kind of break down the question types into these 6 broad categories. There are some extra sort of questions that don't fit those 6 categories, but that's it generally. And to help you out, there are 3 resources that I've provided, and I'll put them in with the recordings. A context quiz to help you get your hang around interpreting data stories for the exam. A summary of past exam questions by these 6 types, so you know where to focus your attention if you're going wrong somewhere. And what I've called an exam cheat sheet, which is just like a one-page summary for each of these 6 things, just going over the basics. Okay. There's also the flashcards, which I'll link again here. I link them for the test, and I'll put them again closer to the exam. So the flashcards, you can go all the way up to chapter 10, practicing all your glossary terms as well. And just remember that if you have any questions about things, feel free to book a time to have a chat with me. I'm available right up until the exam.